Hello, my name is Steven Pasag, and today I'll be teaching you guys how to use the product and the quotient rule. So first off, what is the product rule? So the product rule is basically a formula equation or just a rule used to find the derivative of a function that has two factors multiplying by each other. So the formula would be f prime of x equals u dv plus v du, with the u being the first factor, v being the second factor, du being the derivative of the first factor, and dv being the derivative of the second factor. So just going over what this equation means, it means that the derivative of a function is equal to the first factor multiplied by the derivative of the second factor plus the second factor multiplied by the derivative of the first factor. And yeah, so this is only used when two factors are multiplied together, just to prevent any mix-ups with the quotient rule, which is what I'm about to go over right now. So the quotient rule is a formula used to find the derivative of uh, a function that is dividing instead of multiplying two factors. So the formula goes f prime of x equals v du minus u dv over v squared, with u also being its first factor in this case, v being the second factor, du being the derivative of the first factor, dv being the derivative of the second factor. And again, just going over what this equation means is that the derivative of a function is equal to the second factor multiplied by the derivative of the first factor minus the first factor multiplied by the derivative of the second factor. And this is all over the second factor squared. And just a little disclaimer again, this is only used when using division involving two factors. So for our first example here, we're going to be using the product rule. I made a little mistake here. It should be f of x instead of just x, but let's just pretend that the f of x is there. So it'd be f of x equals x squared minus 4 times 6x cubed plus 5. So our first step into finding the derivative of this equation, we would have to identify the u and v and then find the derivatives of our u and v. So in our case, our u, which would be our first factor, is x squared minus 4. And using the power rule to find the derivative of that, we would get our du, which is 2x. Furthermore, for v, which would be our second factor, it would be 6x cubed plus 5. And then again, using the power rule to find dv, it would be 18x squared. So our second step would be to plug these values back into our product rule. And in doing so, we would find that f prime of x would equal x squared minus 4, which would be our u, times dv, which would be 18x squared, plus 6x cubed plus 5, which is our v, and du, which is our or and d or and 2x, which would be our du. Sorry. And after this, you could simplify and FOIL these terms out. And in this case, FOILing out and simplifying this equation, it would get us to 18x to the power of 4 minus 72x squared plus 12x to the power of 3 plus 10x. So for our second example for using the product rule, we have f of x equals x to the power of 4 plus 7 times natural log of x plus 3. So again, we would have to identify u and v and then find the derivatives of our u and v. So our u for this particular equation would be x to the power of 4 plus 7, and then using the power rule to find the derivative of that, or du, it would be 4x to the power of 3. And then our second factor, which is v, would be natural log of x plus 3, and then finding the derivative of that, we would have 1 over x. Step 2, we would just plug these values back into the product rule once again. And yeah, so plugging these values back into the product rule, we would get f prime of x equals x to the power of 4 plus 7 times 1 over x plus natural log of x plus 3 times 4x to the power of 3. And you could simplify this equation and FOIL it out or whatever, but I just chose to leave it as is. So for our first example, for using the quotient rule, we have this equation, which would be f of x equals x cubed plus 3 all over x squared minus 4. So our u, when it comes to division, or two factors dividing by each other, our u would be our top factor. So in this case, x cubed plus 3 is our u. And then the derivative of that using the power rule would be 3x squared. And furthermore, our v would be our denominator, our factor that's in the denominator. So in this case, it would be x squared minus 4. And finding the derivative of that, we'd find the dv, which is 2x. Our second step would be to plug this all back into the quotient rule, which is v du minus u dv all over v squared. So yeah, plugging all these values back into the quotient rule, we would find that f prime of x equals x squared minus 4, which is our v, times 3x squared, which is our du, minus x cubed plus 3, which is our u, and times 2x, which is our dv. And this would all be over x squared minus 4 squared, which is our v. Okay, so for our second example, for using the quotient rule, we would have f of x equals 3x to the power of 8 minus 7 over 107. Again, we would have to identify the u and the v, and then find the derivatives of u and v. So again, our u would be the top factor in this function, which is 3x to the power of 8 minus 7, and our derivative of that, which would be du, using the power rule, would be 24x to the power of 7. And then our v, which is our factor that's at the denominator of the function, would be v, which equals 107, and finding the derivative of that, or dv, that would be 0. Step 2, just plug those values back into the quotient rule again, and in doing that, we would find that our quotient rule for this equation would be 107 times 24x to the power of 7 minus 3x to the power of 8 minus 7 times 0, all over 107 squared. All right, thank you for listening. Yeah.